reason behind this picture, other than them, for that we don't want to be in this situation. So for us to not be in this situation, we have made a model to suppress the fire as soon as it starts.
Please give your introduction.
So basically, when the fire occurs, it detects. But there's a problem. Even when you put your hand, it detects the frequency, some frequency. But you cannot be as hot as fire. So fire has particular frequency. So for that, we set it to that frequency where it only detects fire and only turns on when fire occurs. And then when the fire occurs, using ESP32, it sends a signal to your phone saying there is a fire in here.
Two servo motors. One of the servo motor, what is the there's a sensor, IR sensor now. We place the motor below the sensor. It rotates the sensor in complete 360 degrees to check the area.
Now there's another servo motor, right? So what that servo motor does is, it's basically we attach one more nozzle which will start the fire extinguisher at the place where the fire starts. So what our model basically gives is also an external safety setup. Like such as this pipes in the room, which are attached to fans, which you can, in movies you can see that sprinkler systems where when fire starts, water gets sprinkled all over. Like that, our model also, IR sensor detects the fire. It will bring a lock position.
Motor which is on the base of the system, and then on the servo motor we have the IR sensor. So the servo motor will spin the IR sensor in 360 degrees. So it will detect, like the delay between is very less. So it will keep spinning really fast. And then if it detects a frequency of a fire, it will be a place that will open the nozzle. So the nozzle is basically for the to close the sprinkler. And once the nozzle is opened, the water will fall. So basically, like Yojit said, it's supposed to be in pipes like these. And we are here to present our fire extinguisher model, the tele-operated fire suppression mechanism, also called the flame pump. I am Sharuti, this is Vishwesh, Yojit and Pranav, and we are team Kanyarasi. So before I tell you about the model, I want to tell you something about us. So before we started to actually work on the model, we all had to learn how to use Arduino. So to be a Kanyarasi, you need robotics training and you need to have special skills to react to different situations in the correct way. Now, my teammates will tell you more about the model.
Which had to be solved with a lot of brain and all. And the solution had to be effective and resourceful. The problem was fire. I know it sounds dangerous. So it can be a boon and a bane. And when it's a bane, Team Kanyarasi is here to solve it. And Pranav will continue how it works.
But how our model came into being, first we had an idea which was to use a servo motor and an IR sensor and attach them together and make the servo motor spin around 360 degrees, and whenever it would detect fire, it would stop and spray water. But obviously that had drawbacks because it needed a lot of extensive complex structures, and also so we made a backup. From that, what we got was we thought to use a sprinkler type of system with the same 360 degrees servo motor rotating around. But that also, the range of which the fire could be detected, and also IR sensors and the servo motor. So each IR sensor is placed in different directions, and whenever the fire is detected, the servo motor turns the pipe into that direction and the water will be sprayed.
Programming part of our model. What we basically used was everything that was taught to us in the class. We didn't go if you see, we started off with initially we started off with if conditional statements. where if we wrote a program where if a IR sensor is detected, then the servo motor would rotate to two more conditional statements, and also use I++ logic for the servo to rotate towards all the directions of the servo. That's everything. And also I important notice, like before we start programming in the Arduino software, since we're using a ESP32 microcontroller, this servo has a different library to which it works with the ESP32. So this is one library that needs to be attached to it.
Problem. Pranav gave us the solution and Yojit told us about the code. So now I'm here to summarize everything and also tell you about the actual physical model. So as Pranav said, we had a very different idea in the starting, but then we modified according to the requirements of like using the equipment which we already have and not making it too complicated. ESP32, the servo motor and the 3 IR sensors and even a pump. So Pranav explained you about how the model actually works, and Yoji talked about the code. So now when we come to the actual physical model of this, we can see that it is a hard sound structure. Basically we made it with the help of cardboard, and we made a box, and the box has IR sensors on 3 sides. We attached the IR sensors with hot glue, and the connections were also given over here. As you can see, all the connections are inside. The servo motor is attached to the pump, so whenever any IR detects the fire, the servo will turn towards that side, and the pump will also turn towards that side. And one small thing I want to mention, which doesn't look like much but actually plays a big role over here, are these supportive structures. So if these supportive structures weren't there, the pipe was actually bending and wasn't moving the way it was supposed to. So these structures also play a really important role, even though they don't look like much.
Okay, good.
Testing that this is a quick response model, and like whenever the fire is placed, it turns immediately towards that side and tries to extinguish the fire. The pump has to be placed in the water, and the pump will keep pumping the water and spray it to the side wherever there is a fire and extinguish the fire. So we are open to any questions if you want. This is a pump, and here water will be there. So whenever it senses the fire, it will turn towards that side and extinguish the fire.
Sensor.
Yeah. So whenever this senses, this motor here, it will move towards that side. And
Feedback for this model. So although the team name is Kanyarasi, nobody is from the Kanyarasi, I think. Anybody zodiac is Kanyarasi? You are? Okay. So that shows like she's the only one participant who is pulling the team. So I really want to appreciate Sharuti in this case, because she is the one who was, since the beginning, the team was being built by her. And even I want to specially thank Mr. Yojit also. He supported Sharuti in building or maintaining the coordination between the team members, and the other participants as well. They have done their best, and maybe with some more what you say, some discipline I can call, with that maybe the team can perform more better. So that's the only one thing which is lacking, because since the coordination was not observed much, so that's the only drawback of the team. But the rest, Sharuti has really managed to pull the team into work. So I really want to appreciate Sharuti and Yojit and other members also. Thank you.